Good morning. Welcome everyone to join our day 2 of the 2017 Hong Kong Open Source Conference. Today we will have over 40 breakout sessions across 5 different tracks, as well as networking sections throughout the day. Hope you will find them useful and return home with new insights to aid your professional development.
Now let's kickstart our first session brought to you by Mr. Chris Van Tai, Chief Technologist at Red Hat. His topic is A Security State of Mind, Continuous Security for Development Operation with Kubernetes. Chris has over 20 years of experience in IT and software. Since joining Red Hat in 2005, Chris has been architecting solutions for strategic customers and partners, with a focus on emerging technologies including IaaS, PaaS, and development operations, and is a frequent speaker on development operations, security, and continuous. He started his career in Intel in IT and managed hosting, followed by leadership roles in services and sales engineer at Loud Cloud and Linux startup. Chris holds a Bachelor of Electrical Engineering from Georgia Institution of Technology. Let's welcome Chris.
Good morning, everyone. Thank you for having me again this year. How many of you attended a previous HK at OSCon? Is this all your first time? Well, welcome. I was here last year as well, and today I'm going to be talking about DevOps. It's certainly one of the hot topics with our customers that I speak with in Silicon Valley. A lot of them are asking, how do they transform their business using a digitalization? And certainly one of the key enablers is how to accelerate application delivery with DevOps. So how do you turn into a center of innovation? And so we'll be talking a little bit about that, and also, what are the security implications around that and some of the enabling technologies such as containers and Kubernetes. Andy Grove talked about how only the paranoid survive. And this isn't about security, but about strategic inflection points in the industry when there are massive amounts of change. And a company has to make a decision. He's talked about how success breeds complacency and complacency breeds failure. And so a company has to decide when they have these massive amounts of change, do they adapt and potentially thrive, or stay as is and potentially fall by the wayside? And certainly we're seeing a lot of these decisions need to be made across many different industries. Take a look at retail, finance, media, transportation, and really affecting any vertical these days, where the leaders and the up-and-comers, the disruptors, are being driven by software innovation. It's enabling them to stay ahead of their competition and become more successful than the incumbents, right, who are resting on their laurels and potentially staying as is. And so what is the key roadblock for existing enterprises to become relevant and to stay ahead and to catch up with these disruptors? Well, it's the rate of innovation within these companies. The typical IT enterprise takes 6 to 9 months in between deployment cycles, whereas their competitors, the disruptors, are releasing software in a matter of weeks. And so what are the challenges the typical IT enterprise has? Maybe it's taking too long to provision, maybe it's taking too difficult to configure the servers, or they don't have access to the platforms and the tools that they need. Or when they do release into production, they're having a high rate of failure, or they're oftentimes betting the entire business on this massive update. And so as I've talked with organizations, one of the commonalities across these companies is that you'll find the slow movers are typically organizationally siloed off. They have their developers, their QA, and their operations organizations completely separate and not collaborating. And just like in nature, you have an island, it evolves on its own, and it creates its own tools and its own language and processes. And as a result, it becomes very difficult to move an application through the pipeline from dev, test into production. And so how do you break down these walls? What needs to change within IT to become not a cost center, but an innovation center, right? And so IT needs to be able to release software when the business needs it. And so that means enabling your software factory to have a process and a culture that's able to deliver new capabilities whenever the business needs it, and not become a bottleneck for innovation. And so when you can release software quickly, you can rapidly scale up the level of innovation that you deliver on behalf of the business. And how are these successful disruptors across different industries, how are they able to stay ahead of the competition? So they've evolved their IT, their software factory, right? They've evolved the process in which they deliver software, moving away from a waterfall development model to DevOps, breaking down the walls, enabling developers to quickly deliver new features and capabilities into production on behalf of the business and their customer base. Microservices is another key enabler, because no longer are you pushing a monolithic application, but microservices allow you to decouple it so you can deliver individual capabilities to the marketplace that are loosely coupled with the overall application on its own pace and with its own technologies. And so a single purpose type of functionality can be updated rapidly without betting the whole business every time you do a release. Right? So you've reduced the risk for the company as well, and you're able to move rapidly, because if there is a failure, you can recover quickly from it. And then also, how do you get that iPhone-like experience of installing software so easily? It takes a matter of minutes to update your phone, new application, low risk. In enterprise, it seems to be so difficult and challenging to actually deploy applications. And so that's the promise of containers, is to be able to package everything that application needs, empower the developer to reduce kind of the footprint from a security perspective, but also from a rapid release perspective. They're able to package that in, loosely couple from the underlying operating system, build it once, and deploy anywhere. Physical, virtual, private, public cloud providers. And so they all go together. You have the new software factory, the actual physical infrastructure around the cloud and the containers, but you also have a new way of running that factory with DevOps, and then the output of that factory is going to be your new microservice-based application, and they go hand in hand together. And so DevOps is all about breaking down those walls and enabling the business from a process perspective. And a key part of it is also a cultural aspect, right? It really mirrors a lot about the open source world. Open source is about collaboration, trust, and transparency. And that's a key enabler for DevOps and bringing that into the enterprise. Also, process. How do you evolve into an automated, continuous integration, continuous delivery pipeline so that you have an automated, repeatable way that you can reliably deliver those capabilities and move it easily from one step to another in that pipeline, dev, test, into production, encouraging developers to check in their source code so that you test this new capability early, and you're able to identify an issue early in the process, because it's a lot less expensive to address something early on than it is once it reaches production. And how do you also enable your developers to have access to a production-like environment on their laptop or in a test environment on demand at any scale? Right? No need to set up a separate standby physical data center just so you can experiment and try things out. And then certainly the technology is a key piece as well. And technology is more often, by these disruptors, they're turning to open source based solutions, whether it's Linux and the underlying container infrastructure or your IaaS platform, or the developer tooling. A lot of it's being based on open source. And these tools are being used to build out this new software automation factory in the enterprise. And does anybody recognize what this is a photo of? Any guesses? I'd say, yeah.
Amazon?
Nope, but they use a lot of what comes out of this factory, and that is the Intel fab that's being built in Arizona. And the reason I show this is because 20 years ago when Andy Grove was going through the Pentium bug, how many remember the Pentium bug? Right, in the mid-90s, there was a key defect in the Pentium chip, which caused Intel a PR nightmare in because they had a defect in the chip that caused them to actually do a recall. They had to issue a physical recall of the chip, and it was a floating point unit error that happened like once every million years or something like that. It was a very rare instance, but they still had to do a recall, and it cost them $500 million of a write-off. And so Andy saw this as a key inflection point. How do we address these issues earlier in the process? How do we ensure that we are able to respond to negative issues out there in the marketplace quicker? And so he realized that behind this fab, which is a key differentiator for Intel, they're able to always shrink the chip and improve the speed without actually architecturally maybe improving. So it's enabled them to be a key differentiator in their lifetime. But also behind this is a software factory. So back then, Andy's made the bet he needs to invest more in a continuous integration or validation factory that enabled a chip designer, when they design their chip component of the overall chip, they're able to submit it to a farm that's now tens of thousands of servers that did some automated testing of that design, allowed them to actually simulate it in a software-based version of the chip as well. And so they were able to improve the quality, they were able to respond quicker to any issues in the marketplace and produce higher reliable product out there as well. And so continuous integration, here today in DevOps is a key part of it of DevOps. And so not only that, but what about continuous delivery? Does anybody recognize what this is a picture of?
Car manufacturing?
Yes, this is the Tesla automobile factory actually. And the reason I show this twofold. One is they're leveraging software to improve the process and the production of these vehicles, the efficiency of which they do, and the reliability and the quality. But also, for the first time, you can buy a vehicle and it gets better in 6, 12, 18 months down the road after you buy it. Not only that, but they're able to fundamentally provide a different revenue stream for their business because they can upcharge by providing additional services and capabilities long after you've made that initial investment. And so it's been totally transformational for this business because they can deliver a software update enabling them to quickly deliver new products and services to the marketplace far ahead of their competition. Right? And who has heard about a vehicle recall? Right? In the States they have, it seems like a press release every couple of weeks about a vehicle having a recall, and a typical manufacturer will have to do a physical recall costing them millions of dollars. In some cases, maybe it's a security issue with a future autonomous driving vehicle. They're able to deliver an update, potentially saving them millions of dollars over their competition. And so a key differentiator and a transformation for the business, because now the revenue stream continues for that vehicle well after the initial purchase as well. And so folks that are leveraging DevOps, CI/CD across the industry, here's some early stats by Public Labs in their annual report. A lot of better, more deployments, shorter lead times, lower change failure rate, and faster recovery from failure. But it's not just about how many times you can deliver capabilities a day, but it's when that customer or when that business needs something, IT can deliver that for the business, right? That's when IT reserves a chair at the CXO table, and they are viewed in the organization as a center of innovation and a strategic differentiator for that business rather than a typical cost center. Right? Too many times I visit customers in IT, I always know where the IT building is in an entertainment studio in Hollywood because it's the worst, oldest building. Sometimes it's not even on the line because they're not viewed as key and strategic historically as a differentiator in that business. Certainly that's changing now. And what about security, right? Recognize these brand names. I mean, these are some of the largest brand names in the United States. And I show these because they represent over 1 billion data records that were breached from a security perspective a couple years ago. And so security is certainly a hot topic, but it was often forgotten. When I joined Red Hat, I would talk to operations folks 12 years ago, and the security discussion I would always be pushed over to the operations side because security wasn't taken seriously in dev or QA or any parts of the other organization. And when I talked to them about their security practices, they typically only cared about the servers in the DMZ. Right? Anything behind the firewall, it didn't matter because the firewall was their protection. And certainly that attitude and that philosophy has been changing with a wave of security breaches and taking security much more seriously as well. And so that's why you see a movement around DevOps called DevSecOps. That's like integrating security into the culture, the process, and the technology, end to end. Right? Security is not just a tool, it's not just for operations. And so as you're transforming your organization to deliver software rapidly, right, you're not going to go out there and have an environment where you have 10,000 containers and go and patch the 10,000 containers. Instead, you're going to shift to a model where you go back into the beginning of the process, rebuild a new version with that component that's addressing a security issue, and then push it through your pipeline. And so containers are a key part of enabling security in this model because they allow you to abstract your application from the underlying infrastructure. And that allows the security team, the compliance team, operations to enforce security, but also allow the developer to quickly move at their own pace and integrate those components that are only the ones that are necessary, reducing that footprint into their actual application container. Right? And so they're able to appease to the operations folks and allow them to kind of force security at a host level and allow the developer to own the application layer, but also with a container, because it's a layered image, the operations team can provide the different components for the base OS. And we'll talk more about that. From a build, ship, and run perspective, this is the basic premise around containers, is that typically you'll build out your container using a build file. And this is important in a security context because now you have a recipe for how your container image is built. If you're a developer, similar to like a makefile. And then once you build that container, you can then share it with a local or a public registry. And this is key because the developer builds and owns the building of the application, and then they're able to share it as is with all its immediate dependencies. Right? Operations isn't adding their own version of glibc or other OS components or application layer components. They're taking exactly what the developer did. And whatever went through testing is what goes through production. And then you can take that container as is and run it on any environment because there's an abstraction layer with the container runtime that allows you to take that image, standardized format, and then run it on your laptop, on your test environment, or in the public or private cloud. And so containers are great and useful, typically at a developer, individual laptop, but when it comes to the enterprise, there are a lot more things to consider and a lot more requirements to be able to manage containers at scale. And so what about scheduling? How do you schedule 100 different applications that are container-based? Maybe they have microservices of a handful each. And so how do you manage and orchestrate that at scale across multiple data centers? Also, in terms of the life cycle, some of these microservices in the container may fail it. How do you monitor and recover from that in an automated way? How do you discover services that you may need and want to leverage in your environment as an application? How do you go out and monitor these applications with multiple microservices? And how do you scale the individual components so that you efficiently use your infrastructure? Right? It's no longer one application per VM per physical system. And then a typical enterprise isn't all about new applications. You have existing brownfield applications. How do you ensure that you can migrate those over to a container-based environment? You need persistence, and to be able to manage that logical grouping of your microservices for a larger application. You need to be able to manage and deploy that so that all layers potentially are at high availability. And then also from a security perspective, a lot of security implications. And so that's where Kubernetes by Google, it's an upstream open source project for container application platform, allows you to manage and provides that functionality. It also is a key enabler for automating security in a DevOps containerized based environment as well. Both process, technology, as well as the culture really encourages that. And so from a security perspective, how does Kubernetes help you out around containers in a large scale environment? Well, we'll talk about a few areas. One is around images, builds, registry, the DevOps CI/CD pipelines, and the host. Let's start out with that. So for the first thing is, treat your containers as immutable. And what does that mean? That means to separate the code from the configuration and the data, right? And so you want to put the code in the actual container image, but the configuration, that can go in things like a secret, or Kubernetes has a concept called config maps, which can store an environment variable or a local configuration file that's dynamically created. And so this means that you're not storing your configuration data in the actual container in a persistent manner. And then if you do need persistent data sources, Kubernetes provides the ability to dynamically mount a physical volume, also allows you to access any remote data services as well. Maybe it's your Oracle database. And so what's inside that container matters for your application code. And you need to be aware of what your developers are pulling down into the environment. And so we did a scan of the public Docker Hub registry where a lot of developers are pulling the components down. And we found that 64% of them actually had some security issues. So you want to have a process within your organization to address this. Not only when you initially pull it down, you want to make sure they're pulling it down from a trusted source, but over time, more and more security notices are released. In fact, here you can see there's a C application, Java, Node.js, and a PHP. Well, the orange boxes and the gray boxes are different components that are pulled in when you build the image. So in the second column, you have the JRE for a Java application, and it's pulling in bash and glibc. Well, the little triangle with the number, that tells you how many security notices have been issued for that component since RHEL 7 was released. And so JRE has 66 security issues and much more since this slide was produced. And so you want to have an ongoing process to address security. And we'll talk about how. You also want to make sure that you're signing your images. So they're a trusted image that you're installing and running. And Kubernetes supports the ability to make sure that they're signed, and if they're not from a trusted source, don't run that in your target environment. Also, when you're building your container images, some best practices. Treat that build file as a blueprint. Version control it. Treat it like another piece of source code. You want to check it into your source code management tool and version control it. Also, make sure when you're configuring these images, don't go into SSH and manually make changes and then log out and save the image, because you don't have a recipe of how to recreate that. And when that person leaves, you have no idea how to do it. And when you're using the build file, rather than say latest version, specify the version so it's repeatable. When there's a security issue and you got to go back and reproduce that environment, you want to know the specific versions that were installed. And also from an efficiency perspective, if you use the run command in the build file, every time you do that, it's actually creating additional layers, so it's a little more inefficient. In terms of storing your registry and pulling down components from a trusted source, consider using a private registry. So you can run a private registry within Kubernetes and provide a trusted source. You can also proxy to other registries as well. And so how do you integrate CI/CD with containers? The typical flow is that you have your developers checking in source code. They then build the container. And then you probably use something like a build image. A build image allows you to kind of have like in the fab you have the clean room. It means you can reproduce how to build that actual target artifact every time. And so a clean build image allows you to build the image, but actually store it not within the build image, but in a separate image as the target. And then you take that target image, store it in your registry, and then distribute it to dev, test, into production as is. And so in terms of those build images, one of the things is the build file allows you in a DevOps environment to have that commonality in tooling and language across your developers, your application owners, and your developers. Today, they might be using different methods, like the core build operations guy may have a kickstart file, your middleware may be using a tarball, and then the developer a jar. Well, with containers, you can normalize that and have a build file that's the same, so everyone's collaborating and speaking in the same language. And when it comes to building your application, you can leverage all these different layers to build your target image. So the operations folks can provide a standard build image, the middleware team can provide a standard Tomcat or JBoss image, and then the developer can layer on top their application. And if there's a security update at any one of those layers, you could trigger an automated rebuild. So the application developer does not have to own the security tracking and updates for the layers that they're not an expert at. Allow the operations team to own the OS layer, allow the developers to own the middleware layer. And so when it comes to CI/CD pipeline, a good best practice is to integrate a security scan in the process. So this is a typical Jenkins pipeline. And so what we've done is we've added a phase after it goes through testing to do a security scan. You could also integrate this with your container registry, so every time a new image is pushed, there's a trigger to do the scan as well. Some tooling to enable automated scanning of your images. OpenSCAP is one such tool. It's upstream open source solution. It essentially provides a way to, through the CLI or a daemon, to scan a physical, a virtual, or a container image that's online or offline. It comes with a security guidelines from your Linux distribution provider, you leverage that. And then there's two ways to scan. You can scan for security policy compliance and security vulnerability. So compliance has your security rules. So maybe don't enable TFTP. And then the security vulnerabilities will check to see if any RPMs have any known security defects. And so it'll generate a series of reports from an audit perspective, and it actually provides a script that automatically corrects any security policy issue in these images. And so you could actually automatically or manually run those on an online or offline container. And so the last part, the continuous delivery of the CD. One of the things that changes in the DevOps model is that instead of taking the jar and pushing the jar file in the Java world, you'll actually build the entire container image by the developer. We'll pull in the OS components, application components, and build that artifact. And you'll take that artifact from your registry and then propagate it into each phase of the pipeline. All right. And so there are different deployment strategies. You have blue-green deployments, rolling updates, canary deployments, and A/B testing. This allows you to automate the delivery of software into production from developers. And it's a key component because you want to be able to quickly release software updates when it comes to security and push it through the pipeline in an automated manner and be able to deploy at scale and upgrade with confidence. And so in a blue-green deployment, typically you have version 1 with the route in production. And then with Kubernetes, you could create a virtual environment that's running version 1.2, run your integration testing. When it completes, in Kubernetes, you just flip the virtual route. So all the traffic now gets routed to 1.2. Now, if there was an issue, I could flip the route back to the existing version. So I can immediately fall back. Also, I can do rolling updates with zero downtime. So I have version 1 out in production. I want to go down to 1.2. So I'm going to do integration testing in my virtual environment. And so it will manually upgrade in an automated manner 1.2. And Kubernetes provides a health check. So when the initialization is complete, it'll actually update the load balancer with that new version. And so now I've got 50% of my traffic going to 1.2. Once I gain confidence, I can roll it out to 100% automatically. So I don't have to write manual scripts. I don't have to have the developers doing things that are really not business differentiating. I can also do automated A/B testing. So I have version A of my application and version B. Maybe version B is a security fix, and I just want to make sure the functionality isn't negatively impacted on the right side. And so I can do a canary deployment to accomplish this with Kubernetes. And so version 1 currently has a 25% conversion rate, getting 100% of the traffic. I've developed this new version which has the security fix 1.2. And I can create an entirely new virtual environment for 1.2, route 50% of my traffic now to 1.2, and I can see that the conversion rate is now 30%, so it actually improved. And then once I gain that confidence, I can go to 100%. Right? And if there was an issue, I could actually revert back. Just lastly, some best practices around host security. So make sure you don't run as root your container images because of security implications. If they hack the container, then they get to the host, then they get to other containers. Limit SSH, use APIs to access logs, etc. Make sure you're using namespaces so you have that virtual separation of UIDs, GIDs, etc., and other resources. Put quotas on all your resources so you don't have a noisy neighbor issue in terms of consuming memory, CPU, network. Make sure you have logging. Kubernetes can aggregate all the logging provide searching, typical ELK stack. And then not only apply security to the images, but also the hosts in your environment. So use your traditional manner of updating your host and applying any policies. Kubernetes can do that as well automatically. And so with that, I want to thank you for attending today's session. Kubernetes also has a lot of key areas around network isolation, storage, API, monitoring, and logging, as well as federated clusters from a security perspective. If you'd like to try out Kubernetes, there's OpenShift Online from Red Hat, allows you to have a free hosted service that allows you to quickly get up and running. You can also download OpenShift's mini shift, which allows you to install on your laptop quickly, or download the OpenShift client, and you can quickly get onto that as well. OpenShift.io is another way to go if you want a true developer experience. Anyway, thank you so much for attending, and I appreciate your attendance today. Thanks.